The distance covered by an aerial photograph is determined by both the focal length of the camera and the tilt of the camera from the perpendicular to the ground. A camera lens with a 12-inch focal length will have an angular coverage of 60 degrees. If an aerial photograph is taken with this camera tilted at 35 degrees at an altitude of 5,000 feet, calculate to the nearest foot the ground distance d that will be shown in this photograph. So here's a diagram that's given. So, okay, we're looking at applications of solving triangles in real life applications, and there's a lot more applications of solving triangles than you might think. So it's a great skill to know how to solve triangles. But at this point, we haven't learned the law of cosines yet, so we can't use the law of cosines here, only the law of sines. Now, this problem is actually a little bit confusing. I had to do some investigating to see how exactly we're supposed to approach solving this. And so what I found was that there's an assumption that they want us to make that, so here's the tilt of the camera, right? Here's the camera's line of sight here. Now, what that means is that, so from there they draw here's the coverage area of the camera, right? 60 degrees, like they said. So if you think about it, we can assume that this line here, the line side of the camera, is bisecting this angle. It's like plus or minus 30 degrees, which actually is pretty makes sense. I guess I kind of missed that. I think that's a pretty good assumption that they could assume that we could figure that out on our own. I mean, maybe they should have told us, but yeah, I think I just missed that. So yeah, you see what I mean though. So they say the camera is tilted 35 degrees from straight down, right? And its coverage area is 60 degrees, so it's going to be like symmetric about 60 degrees from its center line, from where it's out, like from where its line of sight is. So this is going to be 30 degrees, this angle, and this angle is going to be 30 degrees. That's the assumption that I missed. Okay, now they tell us that, we're trying to solve for D here. They tell us that the altitude is 5,000. So this length here is 5,000. Okay, now let's see. What else can we solve for here? Well, what about this angle? This small angle here. Well, we see that this plus this is 95 degrees. 35 plus 60 is 95 degrees. But if we subtract from that 30 plus 60, we can get this angle. So 30 plus 60 is 90, so 95 minus 90 is 5 degrees. Okay? Now, we can also see that when it comes to just this red triangle, we know this acute angle of this red right triangle. It's 35 degrees. So we can do 90 minus 35. And get that this is 55 degrees. You see? You see the red triangle? Okay, but now we have a straight angle here. So what is 180 minus 55? Subtracted these, subtracting this, so 125. Okay, now let's see. We can get this angle now because, okay, 125 plus 30 is 155. Now 180 minus 155 is going to be 25. So this is 25 degrees. Okay, so the end goal is if we can solve this blue triangle, then we've got the information we need because we're trying to get to D. So we've got this angle of the blue triangle. We've got this angle of the blue triangle, 60 degrees. So, okay, we've got all three angles. So 60 plus 25 is 85. So now what is 180 minus 85? $95. So this is 95 degrees. Okay, so now if we can just get a side length, any side length of this triangle, we can solve for D. So can we do that? Well, yes, we've got a right triangle here. We know one of its side lengths, this small right triangle. We know one of its side lengths, and we know one of its acute angles. So we like to solve for the hypotenuse of the right triangle. So let's do, we know that we can say that cosine of 5 degrees is equal to adjacent over that hypotenuse, and we'll call that, just call that x. So we can see that x is going to be equal to 5,000 divided by cosine of 5 degrees. So 5,000 divided by cosine of 5019.1. Okay. So now we have everything we need to use the non-ambiguous case of the law of sines to get side length D. We're applying the law of sines to this blue triangle. We've got a side length and 2 angles. So, okay, let's do, so we're going to need to do sine of 60 for sure, because across from 60, that 60-degree angle is side length D, which we want to solve for. And now let's do, we need to use this side length because that's the only other side length we have. So we need to do sine of 25 degrees over, and here's the side length. Okay. So we can see that D is going to be equal to 5019.1 sine of 60 over sine of 25. So this, you can carry all those decimal points. That's good practice. Times sine of 60 divided by sine of 25. Okay, now they want us to round to the nearest foot. So there's the foot. So 10,285 feet. And there we go.